In the last video, we learned how to actually interact with an array, and now we should probably learn how to look through an array once we have things stored in it. And so this process is known as searching. In this case, we're going to do an example where we do a linear search. And all that means is we're just going to look through the array one by one and try to tell, is this what we want? And so let's say we have an array. I've already created one here. And let's say it's initialized to be a length of 10. So as far as the code goes, I've already written this somewhere else, and we'll look at it in a moment. But the declaration of this is I'm going to create an integer array, and it's going to be called numbers, and I'm going to make it of size 10. And then I set all the things, so I set numbers 0 equal to 2, and then numbers 1 to 4, numbers 2 to 6, 3, and 1. And what we want to do is we want to be able to look through this and find things. And so if we know what the array looks like in advance, we may have an idea of where to look for things, right? Like if I just told you I want to figure out where 6 is in this array, or is 6 in this array, then you would tell me, yes, it's at position 2. If I asked you, is 7 in this array, you might say, no, I don't see a 7. And so this is very easy for us to do as humans because we have a visual look at all these things at once. But the computer can't really do that. It can only load numbers basically like 1 at a time or 2 at a time if we're doing operations. And so we need to be able to look through 1 at a time and be able to tell. And so the naive and kind of just common example of how to do this is to do a linear search where we simply look at the first element. So for instance, if I was again to ask, is there a 6 in this array? What we might do is look at the 0th one, say, is there a 6 there? No, there isn't. And at that point we can check the next one and say, is there a 6 there? No, there isn't. And then we can check the next one and say, is there a 6 there? And then yes, there is. So we found the thing, and at that point we don't need to look through the rest of it, right? We can just say, okay, that's good enough. Whereas if I said, is there a 7 in this array, what we would have to do is we'd have to look at the first one, say, no, that's not a 7. Look at the next one, that's not a 7, that's not a 7, that's not a 7, that's not a 7. So if we find something, we can look until we find it, and at that point we know it's in there. And if we don't find something, then we know we always have to look through the entire array. So what we're going to need to do is we're going to need to look through this array from the 0th position, which is the first position, to the length minus 1 position. And then we're not going to do anything out here because it's just uninitialized garbage, right? If I don't set things out there in a static array where there's extra space, then I really need to not go out there because there could just be random binary in there that represents numbers that either just don't make a whole lot of sense or that might generate some kind of runtime error because we're accessing data that we really shouldn't be. And so let's go ahead and try to do this in the context of a program. Okay, so here I've already done a setup that's very similar to what we just wrote on that whiteboard there. I've created a max size of 10. I've created a constant called max size, and it's going to create an array of that max size. So we're going to make something that's 10, but I'm only going to keep 5 numbers in it. So we're just going to allocate 10 of the spaces there for numbers, but we're only going to fill the first 5. And so we're going to make sure that we don't try to do anything in the unallocated space, or sorry, the uninitialized space. It is allocated, just not initialized, so it's not set to any numbers is what that means. And so I just set it to the same numbers that we had in that example. There's a 2 in the 0th slot, a 1 in the 1 slot is a 4, in the 2nd slot is a 6, 3rd slot is a 3, and the 4th slot is a 1. And what I want to do is I'm just going to ask the user for a number. So here at the top I have a description for it. Ask the user for a number, and we just want to tell them, is this in the array or is it not? And so when we're doing things like this where it's not sorted and we don't really have any sort of information about the array, is we're going to have to, like we said, just run through the whole array and see if we found it. And for the sake of practicing functions, I've also created 2 functions here that we will try to use. One I've already written. It's just called prompt and read, and it just prompts the user for a number. What we're going to do is if we read a negative number, we're going to use that to execute, or sorry, to exit the program. And you'll see this is kind of a common idea. It's called like a sentinel approach, is where you look for some kind of thing that's outside of your range of data that you expect, and then that is what you use to stop your program or know that you're done reading or stuff like that. And so here it reads from cin only, and it will just prompt them. I actually should probably do this. Error value is not a number, please enter a number. So this will, if they enter bad data, like they put A, B, or C, or something like that, that's not a number, it will tell you that's bad, and then it returns the number. So this creates a number called integer, it reads into the number, and then while the number is not valid, so while it's failing, then we're just going to keep rereading it, and then we'll return it. So just as a reminder, functions, right, are kind of like sub-problems. They solve one small problem, is kind of like the goal and the design philosophy with them, is you just want to solve one small problem and then return the result of that problem that you solved. So here our problem is, I need to read a number. We solve that problem by reading the number and, addressing any errors, and then we return the number that we read. So this is like a sub-problem. It's just, its goal is to read a number, and that's it. And so we have a second function here, and I want to mention two things. So we can pass arrays to functions. The syntax in C++ is a little different than other languages. You need to put the type of the array, and then the braces go after the variable name when we're doing arrays. If you're doing it in a function prototype, you need only put the type and then the braces afterwards, which is how most other languages, at least that I'm familiar with, I think that's how C# and Java do theirs too. So this one makes sense to me. This is just a little flipped if you're used to other programming languages. One thing to note about arrays that is important is because of the way arrays are implemented in the actual computer itself, these are always passed by reference. So if you remember, we had those differences. There's pass by value and pass by reference. Pass by value makes a copy. Pass by reference gives the variable itself. And so the array is that second one. It's the pass by reference because an array is a reference type. If you're not familiar with what that means, that's okay. It basically just means that it gives the variable itself rather than a copy of it. So anything that you do to this array is going to happen to it in this function and persist when we return. So just keep that in mind. Arrays are always passed by reference unless you make a copy of it yourself. Anyways, here what we want to do is we want to prompt the user, get their input, and then check if it's in the array. And so in main, this will look very clean because we already have a function. So I need to prompt and read, because this is just going to do all the prompting and all the reading for me. And so you'll notice that prompt and read is that when I use functions, my main looks like way cleaner than if I just wrote this all in there. And so that's kind of one of our advantages of functions, is it allows us to reuse code, and it actually doesn't just copy and paste this. So unlike a macro, if you're familiar with what that is, this doesn't just copy and paste this code directly to where this is, it physically jumps to it, right, is what we said. So when we solve a problem this way, it's both nice for keeping code, keeping there be less code, and also just making everything way more readable. So we're going to read the number. We're going to have to do this again, right? We need to read a number every single time. Prompt and read. So this one reads the first number, so read the first number from the user. And then this one will read the next number. So we need to read every single iteration, right? We need to keep going until we read a number that's a -1. Now let's handle what we do with the number. And so we have a function here that we're about to write. It returns a Boolean, and it's called isElementInArray. So all this does is tell, is this element, being the number that we want to check, is it in the array? So for instance, with what we did earlier, we said 6 was that in the array. So 6 would be our number that we're checking. It's our element, and then we're checking it in the array. So here with this call, you see it takes 3 arguments. The first one is the array. So I'm going to ask, is the element in the array? And the first argument here is the array itself, which I've created an array called numbers, so that's what we're going to pass. We're going to pass numbers. And then the second one is the length of that array. That way we know where to stop, because we said that in C++, static arrays don't give you the length necessarily. And then we have int number to check. So this is just going to be the number that we read. So I need one more paren. So this says, if the read number is in the array. And again, look at how much nicer this is to read if I do it this way. Is if I write this function that has a kind of like a pseudo English name, it just says, is this element in the array? And so we're basically asking if this element is in the array, do some stuff, and if not, don't. So here we'll say cout, and we'll just say the number is in the array, so cout blank is in the array. Otherwise, we'll just say else it's not in the array. Right. And there you go. It looks pretty compact, right? It's only, like, 5 lines in our while loop. So definitely get in the habit of using functions. Very good for splitting up problems. Right, so now we actually have to write the is element in array, and this is kind of like the meat of our program. This is what we're actually writing it for. But we need to look through the array and see, is the number to check in the array? And so the way we said we were going to do it, right, is that we need to look one at a time. So we're going to start at 0, and then if we don't find it 0, we'll look at 1, and then 2, and then 3, and then 4, and so on, right? And if we do find it, then we know we're good, and we'll just return true. And if we don't find it, then we can return false. So first things first, let's make a for loop. We'll do for int I equals 0, I less than length, I plus plus. Like I said, we're going to be seeing this a lot when dealing with arrays. We just want to start at 0, go to length minus 1. And so what we're going to do is we're going to check, is this thing in there? So we'll say if, and then our array in the context of this function is called r. So we're going to check if r sub I is equal to the num to check. So if this element is the number that we want, then we found it, right? So we can return true. In this case, we found it. And otherwise, if we didn't find it, we don't need to do anything. So a common programming mistake I see is somebody will put else return false. And that does not work. So remember, if you found it, then you found it, and that's great. You return true. If you didn't find it, you can't just give up and say, well, it's not there, right? Because if I did that, if I look at the 0th element and say, well, okay, that's not 6, I give up, then it's at the second element. I can't just give up immediately, right? So make sure you're not just returning false and giving up. You have to look through the whole array before you can conclude that, oh, well, I didn't find it, right? So don't put any return falses, or whatever it is that you're doing. Don't stop early. Make sure you check for the whole array. So here I'm going to return false after the for loop, because only after the for loop have I known that I've looked through the whole array, because the for loop goes from 0 to length minus 1, and so I can only know after I've gone from 0 to length minus 1 that it's not in the array. And it really is just as simple as that. It is just these lines of code that would do our linear search. So this is just going to start at the beginning, look to the end, and say, is that thing in there? So now let's go ahead and run this and make sure that it works. Okay, so it's running now. I'll hit enter. So it says, please enter a number to search for. I'll type in 2, and it says 2 is in the array. And that is true, right? Because 2 is right there. It's the 0th element. Let's just make sure it works with some other elements. So 6, so 6 is in the array, 3 is in the array, 1 is in the array, and 4 is in the array. We know that this works because if I type in random stuff like that, it will be like, that's not a number. And if I enter things that aren't in the array, so 7 isn't here, right? We have 2, 4, 6, 3, and 1. If I enter 7, it'll say 7 is not in the array. And it really was just as simple as that. So if we find it, we found it. And if we've gone through the whole array and we didn't find it, then it means we didn't find it. So it's not found. And then we said, well, type in a negative number and it stops the program. And there we have it. So that is how we search through an array in a linear manner. In one of the future videos, we'll look through how to do it, knowing that we have some kind of pre-formatted array, like if it's sorted, then we can speed this up a little bit. I guess one last thing to leave you with is if you find the element, try not to keep going. So if I found 6, you should stop at 6 and not check 3 and 1. Very good idea to do that because it speeds up our program a little bit. And so in one of the future videos, we'll go over how to speed it up quite a bit, actually, especially for large arrays. And we'll get to that in maybe like 2 or 3 videos. But in the next video, I think what we'll do is we'll take an optional lecture where we take a look at vectors in C++, which is a very handy data type. I encourage you to watch it, but it will be something that we don't necessarily test on.